So in this video, we're going to take a look at using this OSI 400 CPU board to test my 6830-004 TIM. This board can be configured to do that. There's actually an application note from OSI on how to do that. I have part of that application note here. I've actually redrawn the application note, the pieces up here that have to do with how the TIM gets wired. I didn't record most of the assembly of this board because it's the same as the assembly was on the original OSI 400 board we built. The sockets are slightly different. I'm not using the 1702 EPROMs here. There's a little bit of difference in wiring here. So there was wiring down here that was pre-existing that had to do with the chip enables on the 2102s. And I've made the cut and I've wired in ICV pin 1 and 2, which is right here. So that's part of the wiring you see down here. The other thing I've done is I've soldered in pins along the edge connector down here, which is A15 through A0, phase 2 clock, etc. So I put wrap pins basically in there, so I can just wrap onto those for configuration. I'm going to, I think, solder directly into the expansion pads on where the TIM will be, but I'm going to wrap down here. This has got the 470 ohm pull-up resistors installed, which are required. I have applied power to the board, and I've seen the two-phase clock up here running. The goal here will be to have a 6501 or the 65, I think it is 12 processor in here running the TIM. The TIM will be outputting serial data to the same header down here we used on the 4000, or the OSI 400 CPU build. And this is just, I've got an FTDI USB cable that plugs into here that deals with TTL level I/O. As I understand how this works, when the system's up and running, the TIM waits for a character to come in and then does its best to auto set the baud rate. I'm assuming it's good for 110 or 300 baud, something like that. So it'll be interesting to see if this comes to life, but right now we need to finish up the wiring here. I have bought this large amount of pre-cut wrap wire, and I'm going to use this just because it gives me some color coding. So I think I'm going to use white to get the phase 2 clock in place. And phase 2 clock comes in on pin 3 on here. Has this ever been opened? No, it hasn't. I don't want to open it very much because oxygen will eventually cause the wrap wire here to oxidize, even though it's, quote, silver plated. The other ones, so let me see if I can just pull one out rather than two. The other bags that were open when I bought this, well, I'm going to get 2 wires anyhow. It is what it is. So the first thing to do is to get on the phase 2 clock input, which is 3. While I'm talking about this, I'll actually mention this too. In the original OSI app note drawing for the TIM, their notes somewhere +5 and ground have it swapped. So it says VSS and then it says +5 here, and it says VCC and ground out here. And I've drawn this correctly, and those connections are hardwired on the board here, so you really can't get them backwards. It's just a documentation error on whoever drew up the documentation. So let me get the soldering glasses in place. Once I spot them, this guy comes to pin 3 here. 1, 2, 3. I'm going to hopefully bring him out straight like that. Soldering pencil is ready to go. It's extremely windy here outside. I don't know if you can hear the wind blowing outside or not. I've been having little minor power bumps on and off all day. Power may go out. If it does, the lab lights here will drop. And the soldering pencil will, of course, turn off. But we'll keep recording because we're running off the batteries in the, of course, iPhone here I'm using to record. So phase 2 goes to B42. So B42 should be marked phase 2. I'm trying to decide the best way I'm going to run these down here. It's probably going to be like this. So we have 15, 14, 13, 12, 11, 10, and phase 2 it looks like it's right about there. So I'm going to trim this about here. and strip. And I'm going to wire wrap the connection. Wire wrapping was definitely a thing back in the era of this stuff. So it was quite feasible it would be used as part of this build. I actually considered, wait, that's a little bit too long. I actually considered using wrap sockets in these two locations and directly wrapping, but I decided not to. So we're coming to 42. Or no, 39 is phase 0. Phase 0 B42. Well, it does say B42. I show phase 0 on 39 and phase 0 VMA on 42. And it said to go to 42, so it goes through 48, 47, 46, 45, 44, 43, 42. That comes to right here, 48, 47, 46, 45, 44, 43, 42. Let's go ahead and wrap that. And it's wrapped. The blue is actually been opened. Once I spot the tweezers, sounds like some kind of power tool outside. I can't get the bag to open here. Yeah, very windy out there this morning, so let's pull a few of these out. And I'm going to work my way up the chain here. So A15. Does A15 go anyplace on here? A0, 1, 2, 3, 4, 5, 6, 7, 8, 9. B40 is read-write. Well, let's go ahead and get read-write hooked up. So I'll use the white again for it, since that's a control signal. I would have preferred that to come straight off of there. So read-write is pin. I should have numbered these and I didn't. Do I have a writing utensil floating around here? I know I just saw. So this is pin 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. We said read-write is on 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here, it looks like. 1, 2, 3, 4, 5, 6, 7, 8, yep, 9 comes out to here. Boy, it is windy out there. We definitely get the wind here in Seattle, you know, or well, I'm south of Seattle, but in the Pacific Northwest. I've been through some very severe power outages here in the middle of really severe winter storms. So it's an interesting place to live. Well, all places are interesting. So that comes to 40. 48, 47, 46, 45, 44, 43, 42, 41, 40. So it's going to come to him. 42 was the one we wrapped before, so that's correct. I just figured wiring like this would be a little cleaner and a little easier to correct mistakes on. Boy, having a hard time seeing. 48, 47, 46, 45, 44, 43, 42, 41, 40. Will he come around the same way there? And he will. I'm going to try to kind of run these out between the resistors that they're kind of aligned to, like so. That takes care of phase 2 and read write. Reset comes to pin 40 over here, and there is a solder pad on 40, so we can do this on the face of the board. I think I will use yellow wrap wire for that. Why not? There's yellow already on the board. This is some of that's oxidized because the oxygen has got in. Boy, that really is oxidized. Well, we'll just cut back at strip fresh. Come on. So that is 1, 2, 3, 4, 5 pins up. 1, 2. So we're saying it's on pin 16. 20, 19, 18, 17, 16. 20, 19, 18, 17, 16 is right here. 1, 2, 3, 4, 5. Did I count that right? 1, 2, 3, 4, 5. Yep, 5 looks like it is right here. I still need to add the reset switch to this. I have powered it up enough to see that there's no shorts, and that it powers up and that the two-phase clock runs. So you are going to come over here to pin 40, and that doesn't look too oxidized. We'll just use the, I think, the full length here. And 40, like I said, happens to have a solder pad on it, so you know, overall, this is a fairly well thought out board. Lots of configuration options with all the extra pads. So that's really kind of nice. And this is somehow going to get ran. Got a very large tree outside the window here, very large pine tree, probably 100 foot tall, and it's not swaying too bad. I'm just fearful, there's a couple of them, fearful at some point one of them's going to come down. It has happened in the complex here, and of course it makes quite a mess. And the closest one here will take my patio and small rear deck out with it. I think the root ball will at least be that big. If it don't think it'll get to the foundation of the building here, but one never knows. So a reset has been done. Chip select 1. There's 3 pins in. 1, 2, 3 is right there. Chip select 1 is already wired up. That was taken care of with the pre-existing yellow wiring you saw on here. This 10K ohm resistor, pull-up resistor, is already here on pin 21. And the lead running off to ICV. Pin 5 is already in place. So really, this is already done. This is already done. All of that's already done. This is already done. This is already done. The cut's already done. That just goes to the chip enabled in 2102, so it's already wired up. So really, I guess we can move into now getting some address lines hooked up. So we're going to go straight to A0. Is 1 pin above. So let's see, A0 is 1, 2, 3, 4, 5, 6 pins up. 1, 2, 3, 4, 5, 6. It's going to be right here. It's 1 pin above. that reset. I potentially could have put wrap posts in these holes as well and wrapped on both sides of this. The reason I didn't is that I will most likely put a ZIF socket into here like I did on the CPU on the other build. I'll probably put ZIF sockets in both locations just so the TIM doesn't get damaged going in and out. And boy, that solder joint doesn't look good on that side. And by doing that, if I had wrap pins along the edges here, I don't think it would fit. So I'm not as happy with that solder joint on this side of the board as I could be. Hopefully the wire won't pop loose here as I just add a bit of solder. That comes to A0, which we show as pin 38, which is 2 pins down on this first connector. Wrap tool. If you watch my videos, you know that we built the Apple II ROM card using strictly wire wrap. So that's 2 pins down. Oh, I'm on the wrong pin. I'm on pin 3 pins down. 2 pins down is A0. Where's A1? Okay, so A0, and these are going to start to work up in order. A1 is on 34, which is way up there. I am guardedly hopeful that this will run. That my TIM is operational since the 6501 was operational. It would be really cool to see this run. I've never seen the TIM monitor live in a system. It would be really cool to be able to demonstrate it. And to have a little single board that runs it. So that is 1 pin up from A0. And boy, the solder on the front here doesn't look great either. A1 is 3 pins up on this connector. I could have a little bit more stripped. So we said it is 321 A321. Should be right here. I didn't get the wrap wire all the way into the tool. I could see it after I set it in place. This is a modified wrap tool. I've mentioned it many times. Its first wrap or so actually is insulation, because the insulation slides into the tool. I said that was 3 pins up on the second connector here, so it's there. It reduces a little bit the odds of pin-to-pin shorts. So that's A2 or A1, right? That's A1. A2 is 1 more pin. You know what? I didn't put that in the wrong place. There should be A2 right here. So A2, we show as pin 13, 20, 19, 18, 17, 16, 15, 14, 12, 13. That makes no sense. That didn't end up right. A2 It's pin 13, 20, 19, 18, 17, 16, 15, 14, 13. Yep. That counts out correct. I'm doing this right in the middle of Elon doing his thing at Twitter. He's announced, I think in the last day, that he needs to hire an actual software manager. You think? It's pretty evident to me that he is not a software developer. I'll just put it that way. He should be. He should come out of that world. Maybe he, I don't know. Where's the stripping tool? There it is. I'm not impressed with what I've seen. I'm going to make a comment here, and maybe this will be controversial. Maybe it won't. This is A2. He just yesterday or the day before sent out the internal memo that basically said we're going to work super hard and super dedicated, and if you're not willing to do long hours and blah blah blah, leave, and I'll give you 3 months of severance. But he never mentions the rewards for all that hard work. It never gets into that. And that really makes me wonder if he understands, check these off, if he understands that the people at SpaceX, this is my opinion, and solely my opinion, the people working at SpaceX break their asses, or whatever word you want to use, they work their butts off because it's space, it's rockets. Who wouldn't? Who wouldn't? And this should be a 3. It's space, it's rockets. It's like the only chance these people are ever going to get to work in that kind of technology. And of course you're busting your butt and killing yourself there, because you're never going to have an opportunity like that again. The rewards are, working in space, or with space and with rockets. And Twitter is a social media company. It is not space. It is not rockets. I think for Elon to expect potentially SpaceX levels of loyalty is misguided at best. He's already let what sound like to me potentially some of the senior engineering staff go. Maybe might call them principal engineers, etc., tenured engineers. There's a lot of terms for them. It sounds like some of those people have already left, have been let go because they didn't agree with him, or they called out his bullshit. That should have been A3, and it was. Excuse me, A3. It looks like they're now trying to hire some of those people back. You don't fix an organization by going in and just throwing people away, and then have to flail and try to bring them back. Okay, something isn't right here. Pin 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That wire is on the wrong place, it looks like. Because this has got to be A4 and A5 right here. 1, 2, 3, 4, 5. So that's 3 is phase 2. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why does that always count out weird? 3, 4, 5, 6, 7. 3. That's why. 1, 2, 3, 4, 5, 6, 7, 8, 9. That white wire is definitely in the wrong place. That white wire is pulling in read write. And because pin 1 doesn't have an extra pad on it there, I've installed it in the wrong location. It just is what it is. It's certainly easy enough to do here. I'd hope to make wiring mistakes on the other side of the board. or where I'm wire wrapping, but that obviously didn't happen. So let's go ahead and clear that location out while we're here. That didn't really get it. I'm not going to get it from that side. That pad's too damn small. That's better. That actually goes to pin 9, which is right here. One, two, three, 4, 5, 6, 7, 8, 9. Yes, that goes there. Luckily, it was an easy enough move because it was just off by 1 pin. So there wasn't a whole lot of length issues. What did I just do? Pin 10. Oh, something is just not right here. What did I just do? Because obviously I did that wrong and I've got myself really confused here. 1, 2, 3, 3 pins down. 1, 2, 3. I pulled the wrong white wire out is what I did. Because there are 2 white wires and I pulled the wrong one out like a dummy. I can't believe I just did that. Actually, I can. Now let's clean this one up. The white wire comes to here. Let's see if we can get this vacuumed out while we're here. And this one goes back up to pin 4. 1, 2, 3, 4. Because it was in the right place to begin with. Tweezers. Tweezers. Boy, that wind's really blowing out there. One, 2, 3, 4. Okay, that is in the right location this time. And now we take this one that's in the wrong location and we pull it loose. That one was going to pin 10. Needs to come up to pin 9, which is right here. If I can get it through the hole. Which is looking more and more doubtful here for some reason. I at one time lived very remote here in the Pacific Northwest, end of a little dirt road, really back in the middle of nowhere, and we had a major ice storm. It was the worst ice storm I've been through here. I've been through 2, and it was bad. And middle of the night I start hearing what sounded like loud gunshots outside, and what it actually was tree limbs snapping off due to the ice load. So phase 2 is correct and read write is now correct. So A4 is right there. And that went on for a couple of days. It was amazing how many tree limbs would just explode from the cold, just crack, and down they'd go. Exciting times. I'm hoping this winter isn't going to become that. So there was some kind of loud vacuum engine outside. Groundskeepers might be here. They've got huge piles of dropped leaves out there that they put together yesterday. They may be out there trying to vacuum them up in this wind, which, yeah, I feel sorry for them. That sucks. That should be A4. A4 is this top pin right here. It's too bad these aren't all in order. You actually are going to... A4 is in there. They've already been out here at least once, and I think twice this year, trying to collect all the leaves up. There's just a lot of them, a lot of deciduous trees. And of course this wind's taking much more leaves out. No surprise. We said that was the top pin there. A4. Pulled a little bit tighter than I would have liked. Does it still route? No, it doesn't. Shit. Shit. Excuse my French. That shouldn't have pulled that tight. I am making a cardinal sin here, reusing a wrap joint. I'm not sure why that did that. Come on, go over the pin. That joint seems absolutely fine. This lead should have been routed up through about there. So that got me through to A4. A5 will be right here. I hear one of the dogs downstairs. I'll have to go down here in a second and look. That if it's Daisy, I need to go down and check up on her. Daisy's very sick. Cushing's, which is just a horrible disease. And she's potentially now got neurological issues as well. She's happy at this point. She's not in pain. She's doing, well as can be expected given what's going on. 321985. 321985. We believe 5 is going to be in there. Should be 321985. 321985 we said was here. Sounds like it's probably Daisy down there, but I need to go check. So I am going to, I think, wrap this video up here. There's just a little bit more wire wrapping like this to do. Just a few more pins to bring up. So that grabbed A4 and A5. We've got A6 through A9 to do. Actually A12 as well. And A13. So there's that many more wires to go. See, it looks like I've already done A13. No, I haven't. Anyhow, I'm going to wrap this one up here. And hopefully in the next video for the TIM, we will see that it's board powered up. And come to life and actually do something. So I hope to see you in that video, and we'll talk soon.